Agarose gel electrophoresis is a widely used lab technique that separates DNA, RNA, or protein molecules by size and charge using an electric current through a porous agarose gel matrix. An appropriate amount of agarose powder is measured with a weighing balance. And then we use a spatula to place the powder into the conical flask. An appropriate buffer is poured into the agarose powder, either TAE, tris acetate EDTA, or TBE, tris borate EDTA. TAE is used with agarose powder to create a conductive medium for gel electrophoresis, allowing the DNA to move through the gel by electric current, separating fragments by size. Then it is heated for a few seconds till the agarose powder dissolves. Once the agarose powder dissolves in the buffer, it is left to cool slightly. Before adding the solution to the electrophoresis tank, it is placed in a fume hood and mixed with ethidium bromide. Ethidium bromide enhances the visualization of the DNA sample. After addition of ethidium bromide, the agarose solution is placed in the electrophoresis tank. Place the comb into the tank, and once the solution solidifies, carefully remove the combs to expose the wells. The loading buffer is added to each sample. It contains glycerol and bromophenol blue, which adds density to the sample, allowing it to sink into the gel. To provide color and simplify the loading process, allowing the user to monitor the progress of the separation. Before loading the samples into the wells, a molecular weight-sized marker, known as the DNA ladder, is commonly used as a standard reference that contains DNA fragments of known lengths. The DNA samples are added into the wells, and then an electric current is added to pull the samples through the gel. The DNA bands travel at different speeds based on their sizes and weight. Once the DNA fragments have been separated, the gel is placed under UV light. Then the DNA fragments can be seen as bands. Each band contains a large number of DNA fragments at the same size, that have all traveled as a group to the same position. Then the approximate size is determined by comparing the DNA bands to the DNA ladder. Polyacrylamide gel electrophoresis, also known as PAGE, is a lab technique separating proteins or nucleic acids, DNA/RNA, by size, shape, and charge using an electric field through a mesh-like polyacrylamide gel. Protein is a charged biomolecule, a chain of amino acids, that moves through a gel or liquid medium under an electric current. They are linked together by polypeptide chains, either single or multiple peptide chains. In the loading buffer, the samples are mixed with SDS, bromophenol blue, and glycerol. SDS helps to denature proteins and give them a uniform negative charge. Then, we place the samples in different tubes. We then heat them up to 100 degrees Celsius to ensure proper denaturation. Prepare the gel and then load up the samples into the electrophoresis tank. The stacking gel is where the proteins are loaded, and the resolving gel helps the separation of proteins based on their molecular weight. We use the micro pipette to load the samples onto the stacking gel. Then we add an electric current, which then pushes the proteins to move from top to bottom depending on their molecular weight. Monitor the movement till the tracking die reaches the bottom of the gel. This shows that the separation is complete. Turn off the power supply, and remove the gel for staining.